Hello, and welcome to Planning for On-Prem Helix Continuous Optimization webinar. I'll be your host today. My name is Dima Seliverstov. I'm a software developer with Solutions Engineering Architect Leaders Team, SEAL for short. First, I'd like to share with you what SEAL team does. We're a team of experienced developers who are customer advocates. We work on reference architecture, discussion, and sizing, and we help customers implement best practice. As a starting point, I would like to share with you the glossary and the terms we'll be using in this presentation. Helix Platform Service is sometimes referred to ADE Platform, which stands for Autonomous Digital Enterprise. ADE is designed to support the new operating models enabled by key technologies that allow us to deliver an expectation customer experience, apply automation everywhere, support enterprise DevOps, drive data business outcomes, safeguard the organization through adaptive cybersecurity, and to accomplish these goals, we leverage containers, artificial intelligence, and machine learning. Some of the glossaries you see in my presentations will be ADE, which stands for Autonomous Digital Enterprise, AI/ML for Artificial Intelligence Machine Learning, BHOM, which is the BMC Helix Operations Management Platform for Events and Monitoring, BHCO, the BMC Helix Continuous Optimization Platform, which is going to be the main subject of this discussion, TSCO, which is our previous BMC Truesight Capacity Optimization product, DSM, which is Digital Service Management, ETL, Extract Transfer Load, which is the technology we use in TSCO and BHCO for importing data into our environment, Kubernetes, which is a container orchestration technology, SEAL, which is the BMC Solutions Engineering Architect Leaders Team, SaaS, which is Software as a Service, and REE, which is a remote ETL engine. We're going to start out by looking at the overview of why container-based architecture was chosen as our solution. We'll look at the Helix on-prem ADE delivery and requirements. We'll explore the deployment steps for BMC Helix platform, the steps for planning successful deployment, education, and upcoming webinars, as well as the reference that you'll see in this presentation. This presentation is part of a series of solutions engineering documentation projects that is being created for our customers to help them understand the deployment requirements and also, more importantly, to ensure that they obtain value from their investment with BMC software. Day 0. Plan and prepare the platform, validation of prerequisite requirements, sizing questionnaire and assessment, as well as the migration assessment from a previous version. Day 1. Build and validate the Helix platform ADE environments with the components that make up the on-prem solution. The migration tools are involved at this point to go from a previous version, and functional use cases. Day 2. This is when we explore the operation and use cases for the BMC Helix continuous optimization environment. The BMC Helix platform service is a pivotal component of the BMC Autonomous Digital Enterprise strategy based on containers. In this session, we will provide information of how to plan and prepare for a successful deployment of the BMC Helix platform service on-prem. Overview of the reference architecture used to implement the BMC Helix platform service in your environment and how this supports BMC Helix continuous optimization will be explored. We will review the prerequisites that are required to support the containerized environment and provide recommendations on the next steps. Why use containers? Some of the advantages are faster solution deployment, better resource management and inbuilt high availabilities, increased environment consistency. BMC has designed and built the new Helix platform using the very latest containerized technologies. There are many advantages to a containerized Helix deployment. Containers are portable. Everything that an application needs to run is encapsulated in the container. The encapsulation of configuration, files, library, dependencies makes the application easy to deploy and eliminates any chance of environmental inconsistencies. Containers are lightweight. This makes them quicker to start and stop. Containers allows for auto-scaling. A container orchestration engine can monitor the services and automatically scale up and down the server as needed. Automating the right sizing of the environment will help to manage the required resources and the associated costs. Containerization also allows for easy upgrades. Containers can easily be upgraded without impacting other services and allows for potential of zero downtime. The analogy I like to use for containers is that of a house, which corresponds to a physical machine, a duplex, which corresponds to a virtual machine, and an apartment, which corresponds to a container. In the house, you're solely responsible for the whole structure. In a duplex, there's a sharing of external structures, and in an apartment, there's both external and internal structure sharing. In a physical machine, the operating system has applications that run side by side, and one can interfere with the other one. In addition, in the physical machine, the load could be very low, so you could have physical machine sprawl. This problem is somewhat addressed in machine virtualizations with VMs, where the same piece of physical hardware can run multiple guest OSs. However, all these OSs contain all the calls to make it a fully functioning operating system. So the apps are somewhat isolated, but there's still a great deal of overhead and inefficiencies. In a container environment, you have the infrastructure and the operating system, and then you have the container engine, which picks and chooses the core functions of the operating systems, and that allows the applications to run in an isolated environment side by side. A container provides an isolated environment in which an app, together with its environment, can run. But those isolated containers often need to be managed and connected to the external world. Sharing file systems, networking, schedule, load balancing, and distributions are all challenges. The Kubernetes project focuses on building a robust platform for running thousands of containers in production. This is called container orchestration. In a Kubernetes environment, a pod represents a runnable unit of work. Usually you will run a single container inside a pod, but for some cases where the containers are coupled, you may opt to run more than one in something known as a sidecar. The Kubernetes uses labels and namespaces to identify things, and it can query these based on the labels. Labels are open-ended. You can use them to indicate roles, stability, and other important attributes. Replication controllers provide a method for managing an arbitrary number of pods. A replication controller contains a pod template, which can be replicated any number of times. Through the replication controller, Kubernetes will manage your pod lifecycles, including scaling up and down, rolling deployments, and monitoring. A service tells the rest of the Kubernetes environment, including the other pods and replication controllers, what services your application provides. While pods come and go, the service IP address and ports remain the same. Other applications can find your service through the Kubernetes Service Discovery. A volume represents a location where containers can access and store information. For the application, the volume appears as part of the local file system. Volumes can be backed up by local storage, Ceph, Gluster, Elastic Block Storage, and a number of other storage backends, including NFS. Kubernetes Architecture. A Kubernetes cluster consists of a set of worker machines called nodes that run containerized application. Every cluster has at least one worker node. The worker node hosts the pods that are components of the application workload. The control plane manages the worker nodes and the pods in the cluster. In a production environment, the control plane usually runs across multiple computers, and clusters usually run multiple nodes, providing fault tolerance and high availability. The control plane components. The control plane components make global decisions about the cluster, as well as detecting and responding to cluster events. The API server is tracking the state of all the cluster components and managing interactions between them. The scheduler distributes unscheduled workloads across all of the available worker nodes. Cluster DNS provides in-cluster DNS for pods and services. etcd stores the information in a key value database for all the cluster configuration data. And the control manager runs all the built-in controllers like node and replication controllers. On each individual worker node, you have a kube proxy that accepts and controls network connections to the node's pods. Kubelet, which manages containers based on incoming pod specification. And it uses the container runtime, a runtime that implements the CRI or the CRI-O or container D. Let's talk about the existing architecture of the Truesight capacity optimization. It is a fully supported product until February 2023, and it will be in limited support until February 2025. Let's start looking at the architecture from the data point of view. We support a variety of third-party data sources, both cloud-based and non-cloud-based, such as VMware for cloud-based, or such as Azure, Google Cloud, or AWS. In addition, we support capacity agents that are installed and running on the pieces of the infrastructure. In terms of the capacity agents, there's an intermediate component that does the collection, transfer, and processing of the data and forwards the data to the ETL engine. The same path is taken to the ETL engine from the third-party data sources. Once the data is collected, it is sent to a database server, which can be Oracle or Postgres, that does the extract, transfer, and load. Once the data is available in the database, the application server it allows the users to do models, analysis, and forecasts. The presentation server is where the views are stored and allows the user to visualize the data. There's an optional component called Truesight Smart Reporting that it allows for scheduling of reports. Let's take an overview of the new Helix Continuous Optimization Architecture. By leveraging containers in Kubernetes, we have the same deployment in our Helix Continuous Optimization Cloud environment and our on-prem environment. The Kubernetes environment allows us to scale out rather than up and provides high availability. The on-premise has additional environment-specific components that I'll talk about later in the presentation. Customers have built sophisticated views, models, and analysis in our existing product. We want to make it as easy as possible to migrate to the new version. A detailed migration BHCO SaaS webinar will be referenced at the end of the presentation. It has already been presented. I do want to illustrate some of the key attributes of the migration process, which is applicable. The starting point for the migration is an existing 2002 Truesight capacity optimization environment. You assess your environment and plan for migration. Then you install the remote ETL engine, download the migration toolkit, you run the migration toolkit, and then you validate the data in your BHCO environment. Let's talk about the data that you can migrate when you run the migration tool. The catalog entities, the relationships, tags and tagging rules, out-of-the-box optimization rules, ETL tasks and custom ETL code, historical data, entity filters, and time filters, analysis and models, custom metric profiles, basic reports, basic report templates, and report results. Summary data marts. Some SQL data marts, depending on their complexity, we have a status that is displayed as part of the migration, which views could and couldn't be migrated, view groups, and custom views with supported templates. The way the migration works is we take your newest data, we migrate it to the new environment, and then start to import your older data. Helix on-prem ADE delivery approach. I will now show a high-level overview of the implementation, following which I'll conduct a deeper dive showing additional technical details related to the successful deployment. High availability. In BMC Helix, there are two main flavors of installation: SaaS and on-prem. In both installations, the preferred method is a stretched Kubernetes cluster, where the control plane and the worker nodes are deployed across several availability zones or data center within a region. A load balancer is used in front of the cluster to provide load balancing between the zones and handle zone failures. There are some regions where only 2 availability zones are available. In these regions, we recommend a replicated cluster instead of a stretched cluster. Multi-region disaster recovery is documented in the use case. Please refer to our product documentation. Let's look at the details. On the left-hand side, there's the user access, the DNS, and the load balancer. The platform supports an Ingress controller, a particular version of Ingress controller with the steps detailed in the documentation. BMC does not deploy or configure the Kubernetes load balancer as storage. We expect this to be done before running the installer. We do have some checks within the installation script to validate the deployment is configured correctly. As you will see, there is a requirement for block storage in NFS. NFS is required for BMC Helix capacity optimization. It can be a sole storage solution for small environments. For scalability, we recommend block storage such as Ceph or GlusterFS. A container image registry is a repository or collection of repository. In our example, we're using Harbor. What is the Docker Trusted Repository? It has the containers from containers.bmc.com that are used in our deployment. BMC highly recommends that you install a local repository. A local repository provides the following benefits: improved performance, where the container images are cached and accessed locally during deployments and upgrades; security, you can implement your security scan of the containers before deployments; and access control, you can control access to the local repository by using authentication authorization. BMC provides full documentation for Harbor and our recommendations. An optional component for BMC Helix capacity optimization is the Helix Discovery Appliance. It is used for dynamic service modeling, the install takes place after you've configured your BMC cluster, your load balancer, your DNS, and once you configure these, you can run the deployment manager to actually install the images from the Harbor into the Kubernetes. There's a couple of requirements that I'd like to point out. Cluster admin permission is required to deploy the product. All the pods run as non-root with restricted privileges. The installation requires an email to be included in the configuration. The reason for this is to allow the admin user to set the password logins for additional users. Configuration parameters are documented, and once you configure them to your environment, you can run the deployment script. Common Services Component Overview. The Tenant Management System is a common service to manage tenants and services, including tenant activation and provisioning. It is the application registry for the ADE platform and responsible for license registration. The Identity Management System is the user's authorization management service, which includes role-based access control. The Single Sign-On SSO is a user sign-on to ADE platform and associated Helix SSO. The Metric Store, part of the data lake. It's responsible for providing APIs to get the matrix data into the ADE platform time series data store, which is Victoria Metrics. It's responsible for converting the received metrics into a generic format and populate the same in another Kafka topic so that other services, for example, anomaly detection, can consume the metrics in their modules. The Event Store, a microservice used for searching events from Elasticsearch DB via domain-specific language. The dashboards is the reporting and the UI visualization of the data available in the ADE platform delivered using Grafana. The log is a service that allows for collection of various sources of unstructured logs, and we apply a structure to unstructured logs to make them easier to analyze. The Helix data lake components. We have Kafka Zookeeper, which is a messaging service used for asynchronous communication and ingestion queues, but not for storage. Postgres is used for structured data across the product and platform. Elasticsearch, used to store ingested configuration and logs. Redis, it's used for ephemeral cache data. Victoria Metrics is where we store time series metrics and aggregation. And MinIO provides a high-performance object storage. BHCO logical architecture. On the left, we have customer environment-specific requirements. The load balancer, the Ingress controller, the DNS, in addition, block storage, which is optional for small environments, NFS, which is necessary for BHCO. They are the common container services which are used among the different products that BMC provides. They use Kafka, Zookeeper, Postgres, Elasticsearch, Redis, Victoria Metrics, and NIO. Has a series of common services that are used. When you install the Kubernetes cluster, you will provision these. In addition, they are other non-container-based components, which are the remote ETL, which manage and monitor and obtain data from your data sources. There's also the capacity agents and the gateway server. So the remote ETL is responsible for collecting the data from these non-cloud-based ETLs and populating it to Victoria Metrics, Elasticsearch, and Redis. Let's look at the deployment architecture in detail. You provision the Kubernetes cluster, create NFS block storage, configure your DNS load balancer ingress controllers, set up a Harbor repository, which could be local, which is recommended, or go to containers.bmc.com. You would run the BMC deployment manager after your configuration, which will configure your on-prem environment. Helix on-prem ADE specific requirements. Compatibility and version supported. Let's start by looking at the container orchestration. You will need Kubernetes 118 to 121, or you can use OpenShift. We support 4.6 and 4.7. Please be aware that the cluster admin permission is required for the deployment. You will need Helm 3.2.3 version, and we support only Ingress controller, and we document how to install it in our documentation. You can use the following container host OS systems. We support the F5 load balancer or compatible with SSL offload, X-forward, header upstream of Ingress, reverse proxy, HTTP back to HTTPS, and an alter response redirect functionality. For the host OS bash shell, we require shell 4.2 or above. For persistent storage, we require Kubernetes storage class that supports high performance IOPS, and for BHCO, we also need NFS. For Docker registry, local Harbor 1.8 above, synchronized with BMC Docker Trusted Repository, or you could, in some cases, you could have direct access to containers.bmc.com, although that is not recommended. For the current BHCO version, we do not support self-signed certificates, so you have to have a trusted root certificates provided by specific vendors, which we document in our documentation. Deployment steps for BMC Helix platform. In this section, I will go through the 6 steps for successful deployment. Step 1, plan and prepare. Obtain your hardware and software requirements. Size the platform. We're going to have a sizing for BHCO very shortly. Step 2, customer builds the containerized platform. This includes block storage and NFS attached to the Kubernetes environment, obtaining the trusted CA certificates, configuring the load balancer, firewalls, URLs, DNS, NTP for time synchronization, and make sure that all those pieces work properly. Make a decision of using local registry. Step 3, download the deployment manager and token. You will access the EPD site, download the containers.bmc.com file containing the token, You will download the deployment script within the same containers that customer token.bmc file, and when you execute the script, you will connect to the local registry or containers.bmc.com to install the software. Step 4 is an optional step, which is to deploy the BMC Discovery appliance. Step 5 is once you configure your files, the configuration files, and I will provide a demo of the installation process at the end of the presentation. You will deploy the BMC Helix Operation Manager, and when your installation is successful, you will receive an email notification where you can set the username and passwords. And then once that's done, you can access BMC Helix Capacity Optimization. Use case planning for successful deployment of BHCO. Let's take a look at the data that you're going to consume. There are two types. There's the cloud ETL, and then there's on-premises ETLs. The cloud ETL, you do not need to install additional non-container components. For the on-prem ETLs, you will need to install a remote ETL and configure it to interact with your environment. For the cloud ETLs, you're collecting data from the resources of public cloud providers, so therefore you don't have to install a remote ETL in your environment. Some examples are Amazon Web Services, Microsoft Azure Cloud Services, Google Cloud Platform Services, and IBM Cloud. So if you have access to these, you don't need to install any additional component. In other cases, you are collecting data from resources that will require you to install and configure the remote ETL. There are out-of-the-box configurations, and there are third-party ETLs that you can install as well. One thing that is a little counterintuitive is that the Prometheus ETL, which will collect data for your Helix environment, is actually an on-prem ETL. So in order to collect data on your Kubernetes cluster, you will need to install a remote ETL engine. What problems are solved with capacity optimization? Gain visibility into resource capacity, utilization, and utilization trends. You use the infrastructure data to collect and understand usage and performance of your infrastructure elements, determine whether the infrastructure elements are used optimally and efficiently or at risk. And then you can plan for future capacity needs. So the advantage of using BMC Helix Capacity Optimization or any capacity optimization tool is that monitoring in events will tell you what is happening in your environment now if you reach some saturation. Continuous optimization will tell you what resources are underutilized, and the determination will be made on historical data. In addition, you can forecast and project when you're going to run out of resources. A lot of the out-of-the-box views already come pre-configured with some of the best practices in order to understand, is your environment healthy right now? And if there's a change in your environment, what will happen? Do you need to increase resources in order to meet your future demands? The problems that we solve with capacity optimization are capacity insight. We're using out-of-the-box views to gain visibility into your infrastructure resources. By viewing the usage and availability of your resources of on-prem and public cloud environments, we can define customized views according to your requirements. You use the views to analyze infrastructure and virtual data. You can do risk management. Out-of-the-box recommendations allow you to detect and resolve capacity risks. What-if simulations will allow to see growth of resources and utilization and add resources to avoid saturation. In addition, you can do resource optimization. You could identify resources that aren't used or resources that could be right-sized. Our documentation comes with a variety of troubleshooting guides that BMC Support has created. Please review the troubleshooting section at the top level. These guides will help you avoid any issues that we've seen before and that have been raised with support issues. Education and reference material. Our BMC education has a variety of resources to allow you to make the most out of the BMC Helix capacity optimization. It includes things such as an overview of the Helix portal, Helix dashboards, Helix continuous optimization overview, some of the fundamentals to get you further along in the journey, fundamentals and authorization profiles, and role-based access. Our subscription services offer 12-month of continuous access to BMC educational offerings per product. Learn what you want when you want it. Get more. Continuous access to your selected subscription content for one product, including any associated courses and certification exams. Exclusive content. Access education services exclusive to subscription. For example, Ultimate subscription contains 6 hours of instructor coaching. Ease of use is a one-stop shop to a complete product portfolio of education. Save money. Save up to 70% off the cost of purchasing the same content separately. Stay current. New content and latest releases automatically added for Enterprise and Ultimate subscription at no additional cost, so your subscription is always up to date. Please contact your BMC education representative for further details. ADE is based on a variety of industry standard components: Kubernetes, OpenShift, Docker, Harbor, Grafana, Kibana, Kafka, Redis, Victoria Metrics. I've shared my experiences with Kubernetes and some of these technologies in a blog I wrote. In my travels in Kubernetes and containers, I've encountered many resources that I found to be extremely useful. So if you get a chance, please check out my blog. It starts out with explaining what containers are, moving to Kubernetes. The first 2 classes are free. And then my experience with certification, some of the helpful links that I found can be located there. Reference that I found to be extremely useful. The first reference is the deployment for BMC Helix operation management. So this guide will tell you what it will take to configure your Kubernetes cluster. Part of that is going to be continuous optimization. It's not going to go into the use cases. The second part is BMC Helix continuous optimization. This will explain to you what Helix continuous optimization use cases are and the problems you can solve. BMC Education provides additional resources for your training in BMC products. And if you decide to pursue certification, the following are excellent resources for Kubernetes administrators. I hope you found this presentation to be useful, and I hope that you got the following out of my presentation: an understanding of BMC strategy, of the on-premises architecture, the various components in Helix, the deployment steps, planning for success use cases, reference and education material, and we will be holding future webinars. In addition to the information presented, there are a variety of self-help resources, such as the YouTube channels, additional webinar information, hot off the presses newsletters. If you do need to contact technical support, it can be contacted via the web, phone, and email. I highly encourage you to follow BMC communities for other questions and concerns and solutions that customers have provided. I would like to present a short demo of the installation process, of the email that you're going to receive, as well as the documentation links for installing the product and in using the product. So let's get started. Let's take a look at the product documentation. Step 1. We want to be able to install the product on a Kubernetes cluster. So the location that you want to go to is BMC Helix IT Operation Manager. The latest version available is 21.3. This will show you the architecture, the getting started, the steps necessary in the deployment, as well as the configuration file. If you follow these steps, you'll be able to configure and deploy the BMC Helix Capacity Optimization product. We'll guide you through the deployment architecture, the necessary system requirements, the ports necessary, as well as the steps for deployment. It'll guide you through the steps to set up the deployment, to set up the container images, setting up the harbor, the ingress controller, deploying the certificates, and the necessary steps. Let's take a look at the default configuration file settings. There's two files that you'll need to configure. File number 1 is the infrastructure.config. It sets up the harbor registry, the various load balancer as well as the tenants, storage options, configurations for the migration, the ETL repository, and the repository. The other file is a much smaller file. It controls exactly what you're going to install. It's going to call deployment.config. By specifying the parameters of this file, you can install the product. So you're installing Helix Capacity Optimization, so you will change the parameters in this file to yes. To exercise the use case of Helix Capacity Optimization, there's a separate link, the BMC Helix Continuous Optimization 22x release. This gives you the latest information about the enhancements that are made and how actually to use the product. It's the same documentation for on-prem and SaaS. It illustrates the key concepts, the capabilities of the product, the use cases, the out-of-the-box integrations, the installation of the remote ETL, the gateway server, the agent, the configuration of the data, both the overview of the ETLs, the out-of-the-box ETLs, the cloud ETLs that we discussed previously, the on-prem ETLs, Our partners ETLs, Oviri, Sentry, how you would extend the capabilities of the product to develop your own ETLs. If you're interested in collecting the data from the continuous optimization agents. So this is more of setting up your collection. And then the next section talks about how you'd use it, what kind of problems you can solve, and some of the best practices. I would also encourage you to join the BMC community. BMC Helix containerization subject is where all sorts of customers who use the product provide feedback, pose questions. They work together to see if this problem has been encountered, and this also involves BMC support, solutions engineering teams to try to help the customers get value out of the product without having to open a support case. I find this to be very helpful, and I suggest that you register for this group, BMC Helix Containerization. I would like to present a short demo of the installation process, of the email that you're going to receive, as well as the documentation links for installing the product and in using the product. Let's get started. Hello, let's take a look at the demo. The first thing I'm going to do is I'm going to make sure that my system has all of the requirements. I'm going to have kubectl. I'm going to have Helm installed. I'm going to have Docker installed as well. So the first thing you notice is in this particular directory, I have downloaded the file from the EPD site that is going to allow me to install the product. In this particular case, it's called Helix On-Prem Deployment Manager. This file is a self-extracting archive. I'm going to execute it. I accept the license agreement, and what's going to happen is it's going to generate the actual install. In this case, it's the Helix On-Prem Deployment Manager in my directory. If I visit this particular directory, I'm going to find several things in there. I am going to find the configuration, which will allow me to specify what I want to deploy from where I want to do it. And the other file to keep track of is the logs file as well. And that's where the output for my install will reside. So let's take a look at the configuration file. The configuration file has a variety of files. The key ones are deployment.configuration. You need to specify this file. The parameters in this file tell you, and I'm just basically using out-of-the-box defaults, and specific installation parameters are available in the product documentation and based on your environment. So I'm going to specify where to get my containers from, the image registry, the optimized registry, and so what I'm going to do is I am going to enable the main features of the product, and in this particular case, for my use case, I'm actually going to enable optimize. So you change no to yes. Great. So that is the first part. And that part tells me where to get my containers from. The second file is a little more complicated. It's called infrastructure.config. It actually tells me the image repository, the image host. So all of these parameters I need to be able to specify. I need to be able to specify my load balancer. All the TMS hosts will have to be defined that are described in great detail in documentation. And some of it is described in the file itself. You have to specify whether you're installing regular Kubernetes or OpenShift. Specify the company name, the tenant name. You'll have to specify your email address configuration. The NFS is mandatory, so for this particular case, you will have to follow the instructions here, including the particular unusual path over here, the ownership 786 and 998. And so you'll have to create an NFS directory, provide the mounts, and create directories that are specified in the file and the documentation. Other parts of the product, initially you could leverage NFS, or you can configure block storage for all of the core components. You have to specify your certificate configuration, and the rest of it is specification for Smart Graph, which is part of Discovery, which you don't need to do. But the other thing is in the documentation. There's an Ingress class. In this particular case, the default can be Nginx, but the documentation will tell you to specify a separate name. It'll tell you to specify where the Helm binaries are, kubectl for the Kubernetes controller. If you use an OpenShift, you'll specify your OpenShift OC command. And then after this, the rest is proprietary, and you shouldn't change anything in this file. But there are a considerable number of things that you need to create in this particular file. Now we're going to do the install. The install does take a little bit of time, so I'm not going to do it in real time because it's not very interesting, kind of like watching paint dry. So I'm going to cheat a little bit. I'm going to start it up. I am going to stop it early in the beginning, and then what the install does is it writes a file into the logs directory. So we'll take a look at that logs file that is created, so we don't have to do it in real time, to see what the activation looks like. And after that, we'll take a look at the email that's received. So let's get started. Let's take a look at the contents of this directory. And in this particular directory, there are two files. The first file is deploymentmanager.sh. And this file is the file we're going to execute to do the install. If at a later time we wish to uninstall the product, we would use the uninstall.sh. So let's get started. It's telling us which build it's using, what it is installing. It's checking the NFS files, checking to see our system configuration, checking the memory. Now it's checking to make sure all of our ingresses are configured correctly, checking our storage class, and I've interrupted it before it's going to take a lot of time. And so the directory that the script is going to generate output to is going to be in the logs directory. And I'm going to go into that particular directory and look at the contents of the logs. In this particular directory, I've activated my client, and I can tell that the client is activated by looking at completed Helix on-prem installation. Let's take a look at the email message just received now. Checking the email message, I've received my activation email. It tells me the URL of my environment, the user, and the next step is to click the link up above to activate the environment. This completes the demo. Thank you very much for your time.